So arc length and sector area, we have just briefly discussed about what is arc. If I am talking about EF is the arc, minor arc, what is that length? If we need to know this length, right? How do I know that length? So one thing we need to know is this angle theta, like how much is this angle? See, I know this entire arc, if I take, let's assume E, and then I draw an entire circle and come back to E, this is also an arc in a way. It's a big arc which is basically the entire circle. What is that called? Circumference. For the circumference, what would be the angle that needs to be covered at the point O? Starts at this, cover entire and come back to this point, which is 360 degrees. Right, for the entire circumference is 360 degrees. And if I am asking you what is the arc length for a theta, right, this is what I need to find, right? So obviously, you know, cross multiply when I have a proportionality like this, circumference into theta is equals to arc length into 360 degrees, right? I'm just cross multiplying this, and 360 goes this side. So basically the arc length would come out to be theta by 360 into the circumference. What is circumference? It is 2 pi r. So it will be theta by 360 into 2 pi r. Very similar to sector area. This is what I need to find out. I have to find out that I know entire circle area would be 360 degrees, like how I found out circumference is for entire 360 degrees. For the required sector area, it is covering theta degrees. I cross multiply, I will get this to be theta by 360 into the area of the circle, which is pi r square. The formula is theta by 360 into pi r square. That will give me the area made by this theta degrees for this entire sector. Perimeter of sector OF is basically I have to add the arc length EF, the minor arc, plus OE and OF. That's basically adding these two. And what are these two? Basically the radius, right? From the center to the point on a circle. So I just basically plus r. This is theta by 360 into 2 pi r. This is what we've talked right here. Arc length I can find out and then add the radius twice for OE and OF, and we are done with the perimeter. So let's solve the problems to understand these formulas better. So the diameter, from the following figure, find the given values that needs to be found. Radius is given as 9 centimeters and this angle is 120 EOF. So let's start. What is the diameter? Twice the radius, so that is 2 into 9 is 18, simple. What is the area of the circle? Pi r square. Pi into r is 9 square, that's 81 pi is the answer for the area of square circle. Circumference of the circle is 2 pi r is the formula, so that's 2 into pi is, obviously I'll keep it pi only, 2 into pi into 9, that is 18 pi. Length of the minor arc EF, so I need to find this arc, right? If you remember, as I said, to find out this, I need to know the angle it is making at the center, so that is, for D it should be theta by 360 into 2 pi into r, right? This is circumference. So to find out EF length, I need to do theta by 360 into 2 pi r. So this is 1/3, 123 is 360, 3 1s are 3 3s are, this is 6 pi. So length of minor arc is EF is 6 pi. Area of the sector OFE. OFE sector area is basically I need to find this entire area, and what is the formula that I need to be using? Theta by 360 into pi r square. So that is 120 by 360 into pi into 9 square is 81. So that's 121s are 123s are. So 81 pi by 3, 3 1s are 327, sorry. 27 pi is the answer for this sector OFE. And finally, the perimeter of the sector OFE is OFE. I need to add this arc length EF, and then I also need to do OE plus OF is basically the radius twice. So right, plus R is the perimeter of the sector OFE. The arc length is 6 pi plus the radius is 9 plus 9. So that's basically 18 plus 6 pi is the perimeter. That's how you solve it.